Hello, this is Mr. Wynn, and this video is over recursive sequences and the binomial expansion theorem. So not every sequence follows an arithmetic or geometric pattern. A famous one is called the Fibonacci sequence. The first term is 0, the second term is 1, the third term is 1, the fourth term is 2, then 3, then 5, then 8, then 13, so on forever. There is a pattern here. So how does 0 turn to 1? Add 1, then 1 stays 1, then it turns to 2 by adding 1, then turns to 3 by adding 1, then you add 2, get 5, add 3, get 8, add 5, get 13. So what kind of pattern is this? So starting with A1 is 0, and then A2 is 1. To get the third term, that 1, you have to add the second term plus the first term. So 1 plus 0 is 1. To the fourth term, you get to add the third term and the second term. So 1 plus 1 is 2. To the fifth term, you add the fourth term plus third term. So 2 plus 1 is 3. To the sixth term, you have to add the fifth term and the fourth term. So 3 plus 2 is 5. Then to get the seventh term, you have to add the sixth term and the fifth term. So 5 plus 3 is 8. So this pattern is to add the two preceding numbers. So really 8 plus 5 gives you 13. 13 plus 8 will give you 21. 21 plus 13 is 34, and so on. So here's the actual formula. The term you want will be the term before that plus the term before that. So the two previous terms, and they give you the starting two numbers. Otherwise, you couldn't start. So that is an example of a recursive sequence. That is a sequence where each term is determined by one or more of the previous terms, and the initial term or terms must be given. Now, unlike arithmetic or geometric sequences where we can instantly find the 100th term by using the nth term formula, recursive sequences require us to find each term one by one and build our way all the way up. There is no shortcut. For security purposes, this is actually a pro, not a con, because you want to make it difficult. So if I wanted the 100th term, I have to find the 99th, which requires me to find the 98th, which requires me to find the 97th. It's a very, very long process. And a side note or fun fact, arithmetic and geometric sequences can be written in recursive form, but there's no need to do that. So quick example. If you get a recursive formula, find the terms by plugging in n equals 1, then n equals 2, then n equals 3, then n equals 4, and so on until you stop or want to stop. So this problem says find the first four terms of the sequence in which a1 is -3, that's the first term is -3, and a sub n plus 1 is equal to 4 times a sub n minus 2. So I'm going to let n equals 1. If I plug in 1 for all the n's, that would be a1 plus 1 equals 4a1 minus 2. Well, a1 plus 1 is a2, and I know a sub 1, they told us, was -3 minus 2. You do some simple algebra. 4 times -3 is -12. Then you subtract 2, you get -14. So the second term, a2, is -14. Now I'm going to let n equals 2. So I put a 2 where all the n's go. So this is now 2 plus 1, and this is now 2. Well, 2 plus 1 is 3, so the third term will be 4 times the second term, which we found was -14, minus 2. Do some algebra, multiply, get -56. Minus 2 gets you -58. Then I'll try n equals 3. Plug in 3 for every n. That 3 plus 1 is 4, so the fourth term will be 4 times the third term, which we found is -58. Minus 2. Do some algebra by multiplying and then subtracting. We get our fourth term. It just found the first four terms, so we're done. The first term they gave us was -3, then -14, then -58, then -234. Alright, so that's everything about recursive sequences. We'll now move on to the binomial expansion theorem. And this is going to be a big slide. It has a lot of information, but it's not that hard. Don't get overwhelmed, but do write everything. So the binomial expansion theorem is a special formula used when we have a binomial raised to an exponent. It can find individual terms directly without having to constantly multiply and combine. And you'll see what I mean when I do the problems. Here's the formula. Again, it looks complicated, but don't worry. Something plus something to the n power, and it could be squared, 3, 4, 5, 1,000, whatever, will turn into this thing. It'll be a number times the a term to the power times the b term to the power plus another number times the a term to the power times the b term to the power, and so on, where that number is called a binomial coefficient. So like I said, it looks complicated, but it's really not. It basically says to find any term, you multiply three things together. A binomial coefficient, the a term to a certain power, and the b term to a certain power. Now there are three important things to notice. And the number of terms is n plus 1, where n is the exponent degree. And you should learn that when you did syntactic division. So for a quadratic degree 2, there should be 3 terms, ax squared plus bx plus c. For degree 5, there should be 6 terms. So that's still true. The powers of A decrease by 1 starting at n. So here it started at the highest power n, whatever this is. Then it goes n minus 1, then n minus 2, all the way to 0. While the powers of the B term increase by 1 starting at 0. So it's B to 0, then B to the first, second, all the way to the highest power. And the sum of the powers in each term is always n, where n is the degree or exponent. Then we have one more thing, and that is the binomial coefficient changes and has its own formula from combinatorics. So this is n CR, n choose R, n combination R, is equal to n factorial over n minus R factorial times R factorial. Factorial just means multiply the numbers from that number going backwards to 1. But don't worry about doing that. We're going to use a calculator. So no need to memorize the formula. We use a calculator to do it. But do learn the steps and how to read it. Now, instead of writing NCR, I can also write parentheses n on top, R on bottom as well. And you read both of them as n choose R. N is still the original exponent degree. R will be the exponent of the B term in the binomial. So R would be 0 for first term, 1 for the second term, 2 for the third term, and so on. All right, so here's an example. If the exponent is 2, FOIL or double distribute is faster. For example, expand 2x minus 3y squared. So the normal way, you'd write it twice. You'd FOIL first, outside, inside, last, or double distribute. Combine like terms, we get our final answer, done. Now notice the degree is 2. So there's 3 terms, an x squared term, an xy term, and a y squared term. The first term is x squared y 0. Now any 0 powers 1, that's why you don't see it. The second term is x1 y1, which is the x1's added 2. And the third term is x0 y2. x0 is 1, so that's why you don't see it, but that's still degree 2. Here's the binomial expansion theorem. We look at the degree, we see it's 2. We should know right away there's 3 terms. Because the degree is 2, n equals 2. Our a term is 2x, our b term is negative 3y. We're going to fill those 3 things into our formulas. So because there's 3 terms, the first thing will be 2 choose 0. Then the first term 2x, the a term, squared, and the second term negative 3y to the 0 power. Then for the second term, it'll be 2 choose 1. Then 2x to the first power, negative 3y to the first power. That third term will be 2 choose 2, 2x to the 0 power, negative 3y to the second power. Then you're going to calculate this. Now, I need to remind y'all something. A negative raised to an odd power is negative. It stays negative. A negative raised to an even power is positive. So this 2 choose 0 thing, we need to use calculator. So in the calculator, over here, 2 choose 0 is 1, 2 choose 1 is 2, 2 choose 2 is 1. Now your calculator is fancier than me, and it'll give you those 2 numbers. Those are my numbers in orange. All right, then I need to, and I should show you the buttons. You press math, go right to probability, and then pick number 3. And you'll put the number on the left and then whatever number right. So for example, 2 choose 2, again, is 1. All right, so I found 2 choose 0 is 1. 2x squared, that's 2x and 2x, that's 4x squared. And then negative 3y to 0 power, and 0 power is 1. So that's my first term. Then for the second term, 2 choose 1 is 2. 2x to the first power, it stays 2x. Negative 3y to the first power, it stays negative 3y. And for the third term, 2 choose 2 is 1. 2x to the 0 power is 1. And then negative 3y squared. This negative 3y times negative is positive 9y squared. Remember, a negative squared is positive. Now let's multiply this. 1 times 4x squared times 1 will just be 4x squared. 2 times 2x times negative 3y. 2 times 2 is 4 times negative 3 is negative 12 with the xy. And then 1 times 1 times 9 is 9 with the y squared. And that's how you get your answer. Now again, if it's square power, faster is the FOIL. But here's where it gets messy. If the exponent is 3 or higher, the binomial expansion theorem is faster. So let's expand 2x minus 3y to the 4th power. Here's the normal way. I write it 4 distribute. I FOIL, double distribute the first 2 parentheses to get this. And I have the other 2 still waiting. Combine like terms. Then I'm going to triple distribute. Combine like terms. Then quadruple distribute. Combine like terms. It's a lot of work. All right, if I do binomial expansion theorem, we know degree is 4, so there's 5 terms. N is 4, A is 2x, B is negative 3y. Still don't forget about the negative to an odd power is negative, negative to even power is positive. There's 5 terms, so I'm going to write the 5 things. So 4 choose 0, A to the 4th, B to the 0. 4 choose 1, a to the third, b to the first. 4 choose 2, a to the second, b to the second. 4 choose 3, a to the first, b to the third. 4 choose 4, a to the 0, b to the fourth. I type the first part in the calculator to get those orange numbers. So I got 14641. Then I do the math, 2x to the fourth. 2 to the fourth power is 16, x to the fourth. And this again is 1. 2x cubed, that's 8x cubed. This stays the same. 2x squared becomes 4x squared. Negative 3y squared it turns to positive 9y squared. 2x the first stays the same. Negative 3y all cubed gets you negative 27y cubed. That's 1. And then negative to an even power is positive, so positive 81 y to the fourth. Multiply each term, I get the same answer, a lot less work. All right, and then the last thing, the binomial expansion theorem is great for finding a single term. You'll see a question that says, find the fourth term of 2x minus 3y to the 10th power. Degree 10 means there's 11 terms, n is 10, a is 2x, b is negative 3y. If I had to write this down 10 times and FOIL combine, and all this stuff, it would take, I don't know, at least a full sheet, maybe 2 sheets of paper, and I'd probably mess up. But if I know the binomial expansion theorem, I just think n is 10, a is 2x, b is negative 3y. The fourth term means r equals 3 because r starts at 0, remember? So we know it's going to be 10 choose 3. Then we know it's a to some power and b to some power. Now actually this 3 is the power of the second exponent. I told you remember that. So we know that's 3, and because these two exponents have to add up to the degree 10, I do 10 minus 3 to get 7. I type this first thing in the calculator, I get 120. I do 2 to the 7th power, that gets me 128, and then x to the 7th. Then I do negative 3 cubed, gets me negative 27, then y cubed. Then I multiply 120 times 128 times negative 27, gets me this gigantic number, then x to the 7th power, y to the 3rd power. That would be the fourth term if I had to find this whole thing. Alright, that's it for the video. Make sure you ask questions in class. Thanks for watching. See you soon. Bye.